upregulation of bone morphogenetic protein 7 in prostate cancer to inhibit HTAT expression and decrease telomerase activity to inhibit replicative immortality. 1 in 6 men will be diagnosed with prostate cancer during their lifetime, and in Australia, prostate cancer is the most commonly diagnosed cancer in men. So why does prostate cancer occur? The prostate is a small gland located below the bladder near the rectum, composed of secretory epithelial cells and stroma underneath the basal lamina. As we age, more cell division occurs, allowing for more mutations to occur, which eventually give rise to cancerous cells. First, there will be prostatic intraepithelial neoplasia. This will generate a reactive stroma that will be constantly remodeling and will alter cytokinesis and growth factors. This leads to prostate cancer cell proliferation at an increased rate by bypassing the normal function of apoptosis and forming a tumor. If this is not treated, the cancer can metastasize to the bone and eventually will lead to death. Current treatments for prostate cancer are broad spectrum and invasive. They include surgery to remove the gland, chemotherapy, radiotherapy, and hormone therapy. The hallmarks of cancer consist of sustaining proliferative signaling, evading growth suppressors, activating invasion and metastasis, enabling replicative immortality, inducing angiogenesis, and resisting cell death. The hallmark that we will be focusing on is enabling replicative immortality. Our drug, human recombinant BMP7, will target cell immortality by downregulating telomerase and in turn shorten telomeres. Telomeres sit at the end of chromosomes and shorten with every cell division in normal cells. The barriers to immortalization of cell lines is crisis and senescence. This is where the telomeres get too short and close to their DNA structure and the cell enters senescence where it cannot continue dividing. Cancer cells can bypass this by upregulating telomerase, which is an enzyme that is activated in around 90% of cancers, including prostate cancer. Telomerase is made up of the major subunits RNA and the catalytic component telomerase reverse transcriptase, also known as HTAT in humans. BPM7 has been seen to activate a pathway which inhibits HTAT expression in a study done by Lucy Sellar and her team in January of this year on breast cancer cells. Hence, our study will try to discover if this occurs in prostate cancer cells. Although this study showed that BMP7 upregulated SMAD3, the exact mechanism is not fully known. However, we hypothesize the following pathway.
BMP7 binds to BMP receptor 2, which is a serine tyrosine kinase receptor. This receptor is located in the prostate cancer cell. BMP receptor 2 will have a high affinity if expressed to BMP receptor 1. BMP receptor 2 will phosphorylate BMP receptor 1. This will then autophosphorylate serine and tyrosine. Once it's in its fully activated state, then it will phosphorylate SMAD3. Once SMAD3 is phosphorylated, it will join SMAD4 to translocate to the nucleus. Once it's in the nucleus, it will downregulate c-MYC. As c-MYC is downregulated, this will decrease HTAT. By decreasing HTAT, it will decrease the telomerase activity and as a consequence decrease cell immortality. First, we will test our drug in vitro by cultivating human prostate tumor cell lining in the lab. We will have a control group and an experimental group where we're going to add BMP7. Then we will compare the telomerase activity for both groups and compare the experimental with the control. Then we will test in vivo by using rats with prostate cancer. We will inject them BMP7 and we will measure the telomerase activity before and after the injection. For our treatment, we will administer the drug to a subject with prostate cancer. This would be an intraprostatic injection with human recombinant BMP7. This will be administered every 2 days for 2 weeks. This will reduce the telomerase activity and as a consequence reduce tumor growth.
Our treatment is a non-invasive, long-lasting solution that would avoid surgery. Testing in vivo would be a limitation due to ethical parameters. As we are targeting a specific hallmark of cancer, this injection would most likely not be effective for patients with stage 4 prostate cancer. We as a team are very excited and optimistic about the findings that can come from this study and what it could mean for the future of prostate cancer treatments. as it would try to solve what has already been solved for various breast cancer cell lines earlier this year, namely the effect of BMP7 on telomerase activity in human prostate cancer cells. It would be a great treatment in combating the replicative immortality of cancer cells.